Welcome back to Labyrinth Academy. My name is Madu Liyanaarachchi. Today we are going to discuss how to answer any IAL Unit 3 Physics practical paper. Let's take May 2019 as an example. This paper is out of 50 and there are 4 questions. In here, the first question is based on uncertainty. It says, during an experiment, a student used the measuring instrument. What is the measuring instrument shown in this picture? It is vernier caliper. Micrometer screw gauge also is in your syllabus. It is just for your reference. It says, showing in this photograph to measure the diameter of a small metal sphere. The metal sphere is shown in the picture. State the resolution of the measuring instrument shown in the photograph. From where do we catch in the answer for here? From this value. It says 13.2. The unit is millimeter. This is up to 10th place. That means first decimal place. So your answer should be 0.1 millimeter. Suppose that here it gives a value 13.25 millimeter. So it is up to 2 decimal places. So there you can get the answer as 0.01 millimeters. Here the second part. Explain why the device is. Talking about this device for what? Suitable to measure the diameter of metal sphere. This is the part of here. It mostly shows some kind of relationship. That means we can get the point resolution in here. When we look at this sphere diameter, this resolution value is too small. When considering that one, we can build up our answer with 2 points. Here, resolution is too small compared with the diameter of the metal sphere. So, percentage uncertainty is small. Like that, you can build up your answer. B part, the student measured the diameter. The reading obtained was the value is given in here. Calculate the percentage uncertainty in the measuring of the diameter. How do we deal with this kind of data pack? Here, we can see the real value it as 20.5. Here, uncertainty is 0.05. We can get the percentage. Here, you get the answer as 0.24%. In C part, the student took further measurements of the diameter and calculated mean. In this question, it talks about the mean. Describe how the student should use this measuring device to make the measurement as accurate as possible. Mostly common answers we can get giving with 2 points. Always look at this instrument, you can see. Suppose if you do not start this with a 0 value, it always create an error. So we can give it as 1 point. Check for 0 error. Another thing, look at this metal ball. It is not completely uniform one. So when you get in different orientations, it may give different values. So definitely we have to consider some different values, orientation points and get in different values and finally get the mean. D part. The student measure the diameter of a second metal sphere. Here they talks about another sphere. Here we have 1, 2, 3, 4, 5 values. Using them, we have to find the mean diameter of here. But we have to be very careful. Can we take all these values? No, it's not. This value is omitted. With that, we can get total of 19, 19.1, 18.9, 19.1. There are 4 values. By dividing 4, final answer 19.0 millimeter comes. Calculate the percentage uncertainty in the mean. Here they deal with this value. So we know the value. Now we want to find out what is the uncertainty. How do we find the uncertainty with this kind of data pack? Here we can go to the finding range method. How do we find range? Out of these 4 values, we can find the maximum value and subtract the minimum. Then we can get the range. In here, 19.1 subtract 18.9, it gives 0.2 millimeters. So uncertainty is half of this one, so it is 0.1. We can get the percentage, so our final answer becomes 0.53%. Nearly it's 0.5%. In E part, the student measure the mass of the pus metal sphere. Again, they talks about pus metal sphere. So there, what is the diameter? It is, here we had value 20.5 millimeters. We can divide it by 2. There we get, this is 20.5 millimeter. There we can find the radius as 10.25 millimeters. So this is about the spherical ball. What is the volume of here? It gives by 4 over 3 5 r cube. We can substitute the values 4 over 3. Here 5 we have. Now we have 10.25. That one cube. Final answer we get as 4.51 into 10 to the power minus 6. Unit comes in cubic meters. So we know to finding density. Density equal mass divided by volume. Here mass, it is given in grams. We have to convert it to the SI unit kilograms. So 35.6 into 10 to the power 6. The values here in kilograms. That one divided by the volume we already calculated in above. It is this. So finally, we can get the answer as 7.89 into 10 to the power 3. Unit comes as cubic kilograms per cubic meters. Next question. It says, the student calculated the density of the second metal ball. They gave a value but with uncertainty. We can find that uncertainty is as how much? 7.75 into 10 to the power 3. We get what is the 2%. So there you get the value as 1 point. It is 155. So once you calculate this value, so what we are finally doing here is with this value, that here getting value with the original, we subtract and find the below range. It is 7.6 into 10 to the power 3 kilograms per cubic meter. So then for this value adding, here subtracting the value adding, we can find the other part of that range. It is 7.9 into 10 to the power 3 kilograms per cubic meter. With that, we can see what they say. What they says. They say, determine whether the two spheres could be made from the same metal. Is it? Yeah. Because this value comes to in between this range. So we can say yes. You can build up your answer using these calculations and giving your own words. Let's go to the second question. A student investigated the extension of a spring to determine its stiffness. This question deals with stiffness. Here, the student suspended the spring from a fixed support. Here you can see that when it hanging, what actually happens? This mass moves so much level down with the original. Suppose is up to here. This increased value gives the extension in here. The student used a meter ruler to measure the measurements, making the measurements of the spring, and the mass was increased. Here it. The student plots graph of here apply force. You can see here y-axis is F and x-axis is X. Against that, they grew a graph. First question asks, describe what the student should do to obtain the data to plot here. 4 marks question. We have to find out 4 main points and you can build up your answer. What are the 4 points? First point, you can say, how do you find in F? Second, you can say, how do you find X? Now in here, we know the question we are dealing with mass. Once you know the mass, here force acting is weight, W equal mg. Accordingly, you can find your force. In this case, original length with the increased length, that difference gives your extension. Now you already get 2 marks. Third point, we have to think about this vertical position. It is a must. So to verify that, check whether it is okay, we want to use a set square. We can use a set square to ensure the ruler is vertical in the position once you are doing in the measurements. Finally, here this is third point also, okay? We have these things for one data pack. We need lot. So we can use a range of masses. There we are getting multiple pairs for your graph. So those points plotting, you can draw this graph. Explain how you would use a graph to determine the stiffness of the spring. Here, what is our equation to relating with the stiffness? It is delta F equal K delta X. In the graph, you can see it looks like y equal mx category. So here our y is F. Here our x is x extension. Then this one matching with here these gradients give K. But which part gradient? Clearly remember only the linear part. Linear parts mean the straight line part gradient you can find, but as much as possibly far away triangle you have to consider to that. So there you can get the gradient accordingly. It's equal to your stiffness. Let's move to the question number 3. The student used an electron beam tube to accelerate electrons towards a thin slice of graphite as shown. Here you can see electron beam source. They are electron beam direct to this graphite. As a result, you can see diffraction. They say the electrons passing through the graphite produce a diffraction pattern. Here we are use electron beam. Diffraction pattern seen. It's similar to effect of the light passing through a diffraction graph grating. The diffraction pattern seen on the curve screen is shown in here. Describe how the student can accurately determine the radius of the first bright ring of the diffraction pattern. Now, we have to give the answer with main 4 points. We'll try to understand what is this, how do we measure, and why do we measure. Here you can see dark spot we call normally as a center maximum. Our first ring appear in here. This is the first ring. We have to find the diameter of it. So we need to choose a suitable device for that one. For the first point, you can point out that one, what is the device you are going to choose. Here I am selecting a vernier caliper. Second point, how do we getting radius? Directly we can't find the radius. Instead, we can find the diameter. Where do we find the diameter? We have to measure the diameter. See, first ring diameter, we have to measure, and that value you can divide by 2. You can get the radius. But keep it in mind, the second point is that, but third point I am going to connect it with this. How? How do we get in? Where do we measuring? Actually, it is like this. You can't find out the edge. Now, first ring, if I correctly mark it here to here, first ring, not go to the there, first ring. So, not these sages very clearly understand. We have to see that, take your paper near to you. I'll little enlarge and show to you. So here, most brightest part normally appear in the middle of the, here, middle part of the ring, middle, not the edge. That is the third point you can point out. You are not getting measurements, the edges, you are getting the measurements only to the brightest or middle part of the ring. So that combination, you can give your second point and third point together. Now, finally, this is one value that in a practical approach, we surely knows we can't get the one value. So we want to get multiple orientations and calculate the mean. So that is your fourth point. Explain how the diffraction pattern provides evidence for the wave nature. Remember, once you answer into this question, they are talking about the electron. You always have to write down that term. If you write down light or something, you can't get marks. In here, we can say electrons diffraction showing. Electrons are diffracted. As a result, we can see its form pattern of bright and dark rings. Why? Because of constructive interference and superposition. We know diffraction, interference are wave patterns. Therefore, it proves us electrons show wave patterns, wave nature. The student determine the radius of the first bright ring of the diffraction pattern for a range of electron energies. The student then calculated to the Berkeley wavelength lambda of the electrons and the angle of diffraction theta. The results are shown in the table. First part they ask criticize these results, including 2 points. Here I'll point out few you can get understand. Once you look at these values, what can you notice? Here, they get different kind of significant figures. We can say then, inconsistent number of significant figures for lambda value. Only 1, 2, 3, 4, 5. Only 5 sets of results are considered in here. So any kind of repeat is not shown in here. No evidence for that. And also if you're looking at the range for here or here, that is too small. Use the result in the table to plot a graph of lambda on the y-axis against sine theta on the x-axis on the grid provided. Use the right-hand column of the table for your proceed data. Now here you have theta values. Accordingly, you can find your sine theta values. I write down 0.3294 here, 0.304, 0.277, 0.237, 0.189. I will share the graph with you now. Here, your x-axis must be sine theta and your y-axis must be lambda. Usually mention the unit in here and you can plot the relevance ones more accurately and most fitted line you can draw. Use the result in the table to plot here. That one we have. Determine the gradient of the graph. 3 marks case. How do you find the gradient in here? You can again go to the graph. They are as much as possible big triangle value you can. This value divide by this value. You can find the gradient. So they are your answer range. It depends that how do you get in the value. 1.10 into 10 to the power minus 10 to. You have to carefully remember, you have to use a unit in here. It's meter, this range, any value possible. The diffraction occurs as the electrons pass through the thin slice of graphite. The atoms in the graphite are arranged in layers. They're talking about layers. The position of the rings in the diffraction band can be approximately, they gave the equation here, where d is the space in between the layers. Explain why the space in between the layers is given by the gradient. Now we have to match this one with our graph. So look at this. N lambda equal d sine theta. In here we know n is a per string we consider, so it is 1 like this. Now I am going to match this to the y equal mf graph. Here my x-axis, my y-axis. Early we drew graph, so this is same gradient gives that. Here. The student carried out an experiment to determine the mass per unit length mu of a string using a standing wave. Stationary wave they are talking about. The standing wave produced is shown in the diagram. The student recorded the following data. Calculate mu. It is just substitution, but careful. Here, mass is given. It is in SI unit. No problem. We know G as 9.81. Here, mu is the one we have to find square root. Frequency also we know. It is 105, but directly we do not know lambda. We have to find lambda first of all. How do we find lambda? With the wave pattern. Here, this to this, you can see the length is L. Here to here, one wave. Here to here, half. 1 and half, 1.5. So, length equals to 1.5 lambda. So, how do we find lambda? Length value given as 1.25. That one divide by 1.5. So, there you can get the answer as 0.833 meters. Now you know lambda value. 0.833. You can substitute in here. So, square root cancel. Directly I am bringing this mu to this side. Square root cancel times 0.25 into 9.81. This one bringing down, but this side becomes squared. Separately squared though, multiply squared. You can find here your mu value. 3.21 into 10 to the power minus 4 unit kilograms per meter. Identify two significant sources of uncertainty in the student's measurements. Here, I'll talk about three things. One for frequency, one for length, one for mass. This one, when you identify node form, uncertainty may create. So, uncertainty in identification when nodes form is 1 point. Cataract's error when measuring the length time, it is another. For the mass, 0 error on mass balance. In here, what do you suppose as a student to get in accurate measurements? So, these points again can consider for this point. For a frequency, we can do repeat and calculate the mean frequency. For length, we can do set square using and reduce the parallax error in length. And also, we can switch off the vibration and we can keep it as a stationary wave. Finally, for mass, 0 balance before each measurements. So they are here 1 point here 1 point, and here you can use 2 points. With this, the paper ends. Thanks for watching. Be sure to check out more videos on our channel. If you like the video, please subscribe for more content.